Hello everyone, my name is Hugo Martínez Ángeles. I am from Querétaro, México, and my institution is División de Investigación y Posgrado, Facultad de Ingeniería, Universidad Autónoma de Querétaro. And today I'm going to introduce the name of my article, Influence of the Use of Ground Enhancement Materials on the Reduction of Electrical Resistivity in Grounding System, a review. On the first place, I'm going to talk about abstract. A grounding system is an indispensable component in an electrical system network, as it is responsible for conducting electric discharge to the ground to the faults caused by lightning strikes or transitive system failures. Soil resistivity, which impedes the flow of electrical discharge into the ground, leads to inadequate mitigation of electrical overload effects, resulting in poor GS performance. The objective of this review is to broadly examine the current status of the gems reported in the literature for use in GS, focusing on their composition. Now I'm going to talk about introduction. Steel and copper are generally the most commonly used conventional materials for developing a route of electrode for the GS. Setting up a GS poses change, especially in high resistivity soil or constrained space, in which case utilizing diverse soil resistance reduction agents is preferred. The GEM significantly reduce soil resistance and impedance and reduce the size of the GS. Now I'm going to talk about the influence of soil on the electrical efficiency of grounding systems. Soil properties significantly influence flow currents to ground and therefore impact the electrical efficiency within a GS. It's recognized that the physicochemical makeup of the soil plays a pivotal role in determining the optical layers of ground resistance. Soil resistivity, impeding the flow of electricity from electrical discharge into the ground, leads to insufficient mitigation of electrical overload effects, thereby affecting the performance of GS. I'm going to talk about design of a grounding system to improve grounding impedance. On the figure 1, we have various ways to design a GS. For example, we can design the GS with simple grounding electrode, multiple grounding electrode connected, grounding plate, or mesh network. Now, I'm going talking about the methodology for evaluating the electrical resistance of a grounding system. In the figure 2, we have Weibull distribution of all filler concentrations. We have 4 distribution, for example, soil resistivity, we can use with spades, potential drops, we can use with spades, selective, we can use with one clamp and spikes, without spades, with this only in this part. Now I'm going to talk about ground enhancement materials as a complement to improve soil resistivity. We have variants of material used in the development of different types of GM or GEMs. We have a natural, from waste, and chemicals. Now I'm going talking about natural materials to improve the grounding system. When it comes to natural gems, they can be derived from agriculture waste products, renewable sources, or materials that occur naturally on the planet. Moreover, these materials are considered environmentally friendly and low cost. In agriculture, for instance, these materials are used to enhance crop growth and increase soil moisture absorption and retention capacity. For electrical applications, these properties are crucial as they directly impact the reduction of soil resistivity, making DGS more efficient by providing a path of lower impedance to ensure that fault currents disperse more effectively into the ground. Now, I'm going to talking about materials from waste to improve the grounding system. Residual materials encompass a broad spectrum, deriving from diverse sources like industrial remnants, urban refuse, and debris from construction and demolition. These are garnered through the treatment and processing of solid, liquid, or gaseous residues are meant to repurpose or reintegrate them into productive circles. Now I'm talking about chemical resistivity reduction methods. Beyond the approach utilizing material source from natural origins and waste products, there are also artificial or chemical methods for reduction resistivity. Chemical enhancement materials effectively decrease soil electrical resistance but simultaneously lead to soil contamination and corrosion of the IJEECS electrode. When employing chemical agents to enhance soil electricity conductivity, it's crucial to acknowledge that this chemical can be washed away by surface runoff and groundwater during rainy periods. We have one table with some investigation about the GMs. For example, Opara et al. Use materials like bentonite, pig manure, charcoal amalgam with household salt. Hasnid et al. Use materials like rice powder, glycol, coconut fiber peat. Lai et al. Use, for example, zeolite, perlite, vermiculite. Ahmad et al. Use China clay, silic, and bentonite. And Full et al. Use palmwood oil and soil. For example, in investigation number 21, the main results is like pig manure produce the best result, reducing soil resistivity from this value to this value, following the bentonite. Moreover, in the investigation 22, there are materials like glycol more efficient in grounding resist, since the resistivity of the IJEECS varied between 33 and 24 sorry. However, this investigation have limitations. For example, in the investigation 21, pig manure is the most efficient materials, but it decomposes over time. Household salt leach out and charcoal alone does not achieve the best result. For example, in investigation 25, the limitation is that the reduction of resistivity effect in rainy seasons. In in 24, the limitation is the use of bentonite condition that result on the mixtures for more only the GS simulation was done. These investigations are from the natural materials. However, we have materials from waste. For example, Chen et al. In 26 use materials like fly ash, cement, and salt. Pedrosa et al. Use coal ash and gypsum from industrial waste. Tatsa et al. Use materials like graphite and activated carbon. The main results, for example, for Chen et al. Is fly ash reduce soil resistivity by 35% after soil stabilization from 22.81 to 14.83. The limitation is it is advisable to carry out more a mixed design to find better results. So we have some investigation. You can see more in my article, and you can read more better in my article, but in this presentation I have some summary of the investigation. On the other hand, when we have chemical reduction methods, we have some material used like sodium chloride, sodium thiosulfate, magnesium chloride, copper sulfate, and ammonium chloride. We have two metal oxide powder, limestone, sodium, chlorine, bentonite, iron filings, and granite powder. And obviously, we have better results than the other products, but we have the limitation as they are chemical products. Their environment use is considered unviable, environment unfriendly. Some compounds showing very high increase over time. So we have these results, and I was saying, and if you want to read more or to know more, I would like to read, sorry, my article in the. I'm going to talk about some conclusions, very summaries. For example, the different tips or types of gems reported by various authors have been analyzed, including those derived from natural mineral waste and chemical materials and waste source. It is found that materials from chemical sources are the most effective in significantly reduce soil resistivity. However, these materials tend to corrode the GS electrode. Natural materials, despite yielding good soil and GS resistivity values and being environmentally friendly, perform better only under moist conditions. Material derived from waste source can be identified, characterized by their residual origin, which implies an environmentally favorable approach by proving a second useful life to these materials. Sorry. And finally, you can see some reference used in this presentation, but in my article there are more reference about this investigation. And finally, I would like to thank you to everyone to watch this presentation, and I would like to read my article in journal, and thank you for your attention, and thank you for the name of the all authors like PhD José Gabriel Ríos Moreno, PhD Rodrigo Rafael Velázquez Castillo, PhD Mario Trejo Perea, and me, Hugo Martínez Ángeles. We are from the Facultad de Ingeniería, Universidad Autónoma de Querétaro. Thank you so much for watching this video.